Hi guys, today we're going to be learning about alkyl halides. So first I would like to give you a basic overview on this topic. So first we're going to discuss the preparation of alkyl halides, and you can do this using three different ways. So the first one is from alkanes by using free radical substitution. The next one is from alkenes by electrophilic addition. And the third one is from alcohols by nucleophilic substitution. And all of these have been covered in their respective chapters, so you can check out the videos for those if you're interested. The next main thing that we're going to be talking about is the reactions of alkyl halides. So in this case, we have two main reactions. Nucleophilic substitution is the first one. And the reagents for this are aqueous NaOH, NaCN, and ammonia. And NaCN and ammonia need to be dissolved in ethanol. The second type of reaction that we have is elimination, and for this we have two main reagents, just NaOH and KOH, and both of these have to be dissolved in ethanol. So this is a basic overview on alkyl halides. So next we are going to be talking about Sn1 and Sn2 reaction mechanisms, which are mainly exhibited by the type of nucleophilic substitution reactions of alkyl halides. So the first one is called Sn1, which is exhibited by secondary and tertiary alkyl halides. So now we're going to discuss what secondary and tertiary actually mean. So a secondary alkyl halide is one in which the central carbon, which I've marked over here, is going to be directly bonded to two other carbons. So the central carbon is bonded to this carbon and this carbon. So because it's bonded to two carbons directly, it's going to be classified as a secondary alkyl halide. And over here, for this one, this is going to be tertiary, as the central carbon is bonded to three other carbons. So the condition for this reaction is going to be that it needs to be heated under reflux. And the reagents that you're using is going to be your tertiary alkyl halide, which is this one. And you're also going to have NaOH. So now, because this is a polar compound, the bromine is going to be more electronegative than carbon, which is why it's going to have a partial negative charge. So because of the difference in electronegativities and because of the conditions that you have, this bond is going to break heterolytically, and it's going to give you this carbocation, which is going to be positively charged, and a bromine minus ion. Now this carbocation, since it's positively charged, it's going to be attracted to the OH ion from sodium hydroxide, which is going to be your nucleophile. And this is going to result in the formation of an alcohol and also NaBr, because this Br is going to be attracted to sodium, and it's going to result in the formation of NaBr. So this is Sn1 mechanism. So now we're going to look at the energy profile diagrams for Sn1 reactions. In this case, the rate is going to be directly proportional to the concentration of your alkyl halides. So these square brackets, they denote your concentration. So in this case, if you double the concentration, your rate is also going to double. So now let's look at the energy profile diagram for this. So first over here, you are going to have your reactants, which in this case are your alkyl halide, and you have NaOH. So what's going to happen is the first step that's going to take place is going to be the formation of the carbocation. So your carbocation is going to be the product of the first step. So the carbocation is going to be the product of the first step. And it's also going to be the reactant of the second step. So the second step is basically going to be the reaction of the carbocation with the OH minus ion, sorry. So this is going to result in the formation of your product, which is going to be the alcohol and NaBr. So this is the energy profile diagram for Sn1 reactions. Overall, the reaction is going to be exothermic because your reactants over here have a greater energy content than the products. Okay, so now we're going to be discussing SN2 mechanisms. For this, your reagents are going to be the alkyl halide and NaOH, and the condition is going to be heat under reflux. And this mechanism is only applicable for primary and secondary alkyl halides. Now, primary alkyl halide is one in which the central carbon, which is this one, is going to be bonded to only one other carbon. So this is going to be your primary alkyl halide. Now in this reaction, bromine is going to be more electronegative, so it's going to have a partial negative charge, and carbon is going to have a partial positive charge. So what's going to happen is your nucleophile, which is OH, which has one lone pair, is going to be attracted to this carbon atom. And this is going to result in a pentavalent transition state. And this state is going to be negatively charged. So what's going to happen after this is that this bond is going to break heterolytically, and it's going to result in the formation of an alcohol, which in this case is going to be a primary alcohol, and a Br- ion. And this Br- ion is going to react with sodium to produce NaOH. So this is the SN2 mechanism. Now let's talk about the energy profile diagrams for SN2 reactions. These type of reactions are called biomolecular, as the rate of these reactions depends on the concentration of two substances, which in this case are your alkyl halide and the OH- ions. So now let's look at the energy profile diagram for this particular reaction. Over here you're going to have your reactants, which are the alkyl halide and NaOH. This is your activation energy, which is the energy required to start the reaction. And at the bottom, you're going to have your products, which is going to be your alcohol and you're also going to get NaBr, which is a salt. And this reaction is going to be exothermic because the enthalpy change is negative. Now we're going to be discussing why some alkyl halides undergo the Sn1 mechanism and why some alkyl halides undergo the Sn2 mechanism. So let's start off with the first reason, which is carbocation stability. In this case, you have a primary carbocation, which is going to be less stable than a tertiary carbocation. Since this carbocation is surrounded by three different R groups, the positive inductive effect is going to be greater, and this carbocation is going to be more stable, so it's going to be more likely to be formed, which is why this undergoes Sn1 reactions. In this case, this carbocation is very unstable and is less likely to be formed. Now let's look at the second reason, which in this case is steric hindrance. As you can see around this carbon in this tertiary alkyl halide, there's three different R groups. Because these three different R groups are larger than the hydrogen groups around the primary carbocation, there's going to be less space for the OH to come get attached, and it's going to be less likely for this pentavalent transition state to form, which is why tertiary alkyl halides go through the Sn1 mechanism. Now let's talk about the reaction of alkyl halides with ammonia. In this case, your reagents are going to be halide and ammonia. And the conditions for this is that the ammonia needs to be in ethanol. So the first step of this reaction is going to be the reaction between the alkyl halide and ammonia. And in this case, one of these hydrogens is going to be substituted by Br. So you are going to get a primary amine. An amine is a substance that contains the NH2 group as an anion over here. And you're also going to get NH4Br, which is a salt. If you use ammonia in excess, this reaction will stop right now. However, if ammonia is not in excess, it's going to continue as a chain reaction because this nitrogen, even after this reaction has taken place, has a lone pair. Because it has a lone pair, it can act as a nucleophile, as it's going to be attracted to the partially positively charged carbocation. And since in this case we are using a primary alkyl halide, this is going to go through the SN2 mechanism. So if ammonia is not in excess, the following steps that I've marked over here are going to continue on. So in the first step, this hydrogen, like right now you have two hydrogens, so one of these is going to be substituted by Br, and you are going to get a secondary amine. After this, another hydrogen is going to be substituted, and you're going to get a triethylamine because this nitrogen is going to be bonded to three different R groups over here. Now in each of these steps, you have one nitrogen because it has a lone pair. It's going to continue on reacting with the alkyl halide. So in the last step, this nitrogen, as you can see, I've made it here with the lone pair. It's going to be attracted to this carbocation because since bromine is more electronegative, it's going to have a partial negative and carbon will have a partial positive charge over here. So this, since it's a nucleophile, it's going to be attracted to the partial positive charge. So you are going to get a salt, which is called, in this case, this ion is called triethyl ammonium.